Okay, so welcome everyone. Thank you for having me here at this GDG Montreal meetup. And I'm going to talk about the Dkmp architecture, where D stands for Declarative Uis and KMP stands for Kotlin MultiPlatform. And then we are adding this extra sauce, which is the MVI pattern, which is actually the pattern, the architecture, which is able to make the two work the best together. My name is Daniele Baroncelli, and I think the presentation is going to take about 45 minutes, I think. Okay, let's start. Yeah, so traditionally, app development has always been about developing whole apps without sharing much code at all. So if a company wants to develop 3 apps, Android, iOS, and web, they would develop 3 whole apps without sharing, in most cases, not much. Even though I was talking to Samuel earlier and he was telling me that actually their company, they were quite keen on sharing code, and they've been using C++ for a while. He told me from 2014. But I think for the future, if you want to share something, you would not probably use C++ anymore, and you would use something which I think we all love, and it's Kotlin. So this introduced our architecture, which is the Dkmp architecture, which is an architecture based on Kotlin multi-platform. And in this architecture, we are able to share up to, I mean, really, literally 85% of business logic, and then we just leave the 15% for the UI layer, which is the only platform-specific part of the app. And as you can see, like there is a lot of save of resources. You know, this is like probably less than half of resources required to do such a kind of development compared to developing whole apps. So let's see more in details about the Dkmp architecture. So it's based on a business logic and UI being fully decoupled. And you only share the business logic, which, by the way, is the biggest part. And we will show is, I mean, not in detail, but you know, it's from the experience. It's in this architecture, you're able to have 85% of shared business logic, and we'll show why that number is so high. So it really, many people they think, wow, it's incredible, 85% of business logic you are able to share. Yeah, it is true, and we're gonna show why it's so much, because we are really able to put all the state of the application as well inside the shared part of the business logic. And by not sharing the UI, we also gain the flexibility of being able to target any device of the present and of the future as well. So, for example, think about the new Huawei operating system, Harmony OS, which we don't know much about it, but we can expect that they are going to have their own UI toolkit. And in this, if you develop an architecture like DK with this architecture, if you go back to the same diagram, you just need to add, you know, the 15% of the Harmony OS UI toolkit, and you can also reuse the business logic, the shared business logic. This is something that would not be possible with other framework, multi-platform framework like Flutter or React Native, because if you use those, you lock yourself into their specific framework, which is made of both language and widgets. So this architecture really allows a lot of flexibility, and we believe it's like a very safe investment if you don't want to lock yourself in any platform, but you want to have the flexibility. So let's talk about the 3 pillars about the Dkmp architecture. The first pillar is the Declarative Uis, which is really a fresh kind of topic. As you know, most of you, that yesterday there was like this big announcement of the beta stage of JetpackCompose, which is the new Android toolkit, which is a Declarative Ui toolkit. And in iOS, in 1.5 years ago, there was launched already a declarative UI toolkit, which is called SwiftUI. So this is both JetpackCompose and SwiftUI. They're really the future of mobile, and they're really pretty recent frameworks. And we are going to talk more in detail about those two. And then the second pillar is Kotlin MultiPlatform, which is a multi-platform technology that finally makes sense and really works. And then the third pillar is the MVI pattern, which is based on a unidirectional data flow and a single source of truth as the app state. And we are able to achieve this without RxJava, which is traditionally the technology that you would use for an MVI pattern, at least at the beginning. Even though MVI pattern is quite recent, it's just a few years old, and that we start to talk about those. So before I go deep into the presentation, I would like to thank everyone, especially these guys you see in this slide, which made a lot of research already on these three topics: MVI, Kotlin MultiPlatform, and Declarative Uis. And in my presentation with my architecture, what I'm trying to do is to connect the dots of all this research and knowledge that have been shared by other guys. Like in my case, I really took a lot of attention to what these people said. And okay, so let's explain. Let's give a very simple representation, a very simplified representation of what the app development has been in the past and what we think it can be in the future. So in the past, we tend not to share any code. And we had as the UI layer an imperative UI layout. So imperative is what we call the classic UI toolkit in Android, which is the view-based system, and in iOS, which is the UI kit. And one interesting difference between the declarative UIs and the imperative UIs is that the imperative UIs always had IDs. All the components, all the elements in the UIs had IDs. Think about in Android, the XML layouts, they have, always have an ID. And then if you want to associate data, which is coming from the view model, you want to associate two components, you always need, in any case, whichever angle you see, you always need an extra layer of code, which is the code which has the find view by ID, which is what couple the view model field data with the layout component. And even though recently there is like the view binding, which is Android really try to simplify and to make it better, but still, even if you use view binding in Android, you still need an extra layer of code if you want to couple the layout and the view model. So this is something, a very important and difference already, in the declarative UI, because in declarative UIs, we don't have IDs at all. So you don't define IDs at all. So you are able to apply data, which is typically, obviously coming from a view model, you're able to apply directly on the layout. And this is really simplifying the code a lot, and is really removing lots of boilerplate code. And this is also one of the many reasons why this 80% now 85% number is so high. And yeah, so I think another interesting concept is that before, in the past, anything that you wanted to any business logic in the client that you wanted to share, you had to replicate for as many platforms as possible. For all the platform that you would use. And so it was kind of expensive to have business logic in the client because it required replication. So with an approach of multi-platform, we really have the advantage of being able to write client-side logic just once and reuse in all the platforms. So this makes it very inexpensive to write client-side logic. And client-side logic is always associated with user experience. So it's directly proportional. So the better user experience typically it requires more client-side code, more client-side logic. And so we can predict that with a multi-platform, I mean, not predict, we actually proved already that, with a multi-platform approach, apps can even be much better quality. They can provide even a better user experience. Okay, so let's summarize. So in the past, we had a UI layer and view model, which require a coupling middle layer. And in the future, with the declarative Uis, we are going to have a UI layout and view model, which are fully decoupled. So in the past, we tend not to share code across platform. And in the future, we are going to be able to share 85% of code. Then in the past, you would use patterns like MVC, MVP, MVVM. And in the future, it makes sense to use a pattern like MVI, which is based on a single source of truth for the UI layer, for the app state of the app. And then what I was saying, in the past, we tend to have a thin client, so a very limited business logic on the client. And in the future, we will be able to provide a much better and more sophisticated client business logic. Okay, so very important thing to say when talking about this Dkmp architecture is that it's aimed as greenfield projects. So the aim of this architecture is not about gradually introducing declarative Uis and KMP to existing projects, because you can use Kotlin MultiPlatform in many different ways, right? You can actually use it incrementally. So use Kotlin MultiPlatform to just share a module and to create a module, a multi-platform module, and share across the different platform by keeping the architecture, the existing app as they were, just to have a common module. But that's, in my personal opinion, is not very interesting. Although many companies probably, or many apps, they don't really have the privilege to be able to write an app from scratch, because they have probably a lot of legacy code, and they would need to, if they are interested in multi-platform, they would take a very incremental step. But I think it really makes a lot of sense to talk about brand new architecture, especially when there are frameworks like Flutter, which have become really popular in the last couple of years, which means if they become popular, it means that there are people who are interested in creating new apps from scratch. And I think Dkmp, in particular Dkmp with these declarative Uis, can be really a very good substitute, and in my opinion is far superior to Flutter. Okay, so the aim of Dkmp architecture is to have a clean, solid, and future-proof architecture, making no compromises with the past. Very important also to say that Dkmp is not a library. It's actually, as it's written, an architecture, and is fully based on the official framework. So you don't really need to go into third parties code. It's really the concept that is providing, and is going to use all the things that already exist and they're official. Yeah, so this is one very important aspect of the Dkmp architecture is the separation of concern. So from the data point of view, we would have the web services that would provide data. Okay, then on the client, you would have the data layer, which would just process and cache data. And then you would have the view model, where you would format the data, and then the declarative Ui, where you visualize the data. So this seems trivial, but it's in most apps at the moment, the separation between all these components is very blurred. In traditional Android development, it's really blurred. And in Dkmp, we really try to make it very neat. And by making the distinction between UI, view model, and data layer very neat, we can really have a very clean architecture. And it becomes a real joy to maintain a code which is structured in such a very, very structured, very clean way. Okay, so let's talk about the first pillars that we mentioned about the Dkmp. So it's the declarative Uis. And let's see a timeline very quickly. So Declarative Uis became popular on the web thanks to React Native, to React.js, which is a framework created by Facebook in 2011 and open source in 2013. And on mobile, the first declarative UIs, they were React Native, which is the mobile version of React, which was released in 2015. But then more interestingly and more importantly, I would say, Flutter really made a difference. I mean, the introduction of the Flutter declarative UIs on mobile really had an impact. And probably Flutter is what showed that declarative UIs really simplify mobile development, and it makes mobile development much better, much easier than using the existing UI toolkits. So yeah, for this reason, for the success probably of Flutter as well, Google started to create their own declarative UI toolkit, which is JetpackCompose, and it was introduced experimentally in May 2019. And then the same year, like a few days later, at the Apple WWDC, iOS also announced their own declarative UIs. So here it's very interesting to notice that while Google introduced JetpackCompose as an experimental UI toolkit, Apple actually in June 2019 presented it as version 1.0. And we believe that it was not really 1.0, because the first version of SwiftUI had quite a lot of problems, which luckily have been fixed in version 2.0, which was released a year later. Okay, so let's see some characteristics quickly about the declarative UI. So the declarative UIs, they just describe how the UI looks like for the different app states, but they are stateless, so they don't manage the app state directly. And the UI layer in this way can be really decoupled. It can be really decoupled from the view model. We can see later more about the statement we are saying here. So let's describe a very high-level difference that we already mentioned between the imperative UI toolkits and the declarative UI toolkit. So in the imperative UI toolkit, as I was mentioning, we always had an extra layer of code which is needed to apply data. So you have the data, you have your structure with the fields. You always need to couple the ID through code, from code to the HTML layout. And the same happens in both Android and iOS. So in iOS, you would have interface builder where you define the components, the UI components, but you still need to couple to link these elements in code. So in declarative UI, you don't have this layer at all, as you can see here. So we don't have the extra layer code. So our data, our data structure, we are able to apply directly the fields, the data, the elements directly on the UI without even defining an ID. Just you have this element and you associate a field, a data element to it. And okay, so talking about JetpackCompose more in details. So JetpackCompose was announced, as we said, in May 2019. And in August 2020, reached alpha. And then actually yesterday, we had the very important announcement of the beta stage. And there was this big event by Google called the Android Show, where really they were very enthusiastic to have reached this very important milestone, which it is for the whole mobile, honestly. I mean, JetpackCompose is here to stay. And during this presentation, I'm gonna show very small clips from yesterday where you understand this a little bit better. And then at the end of, I was talking with guy in the Compose team, and they confirmed that they're gonna reach 1.0 by the end of the year. So this is sure. So JetpackCompose is gonna become stable version 1.0 by the end. We don't know exactly which month. It might be August, or it might be November. We don't know, but for sure it's gonna be during this year. And this is going to really trigger an incredible revolution. So JetpackCompose requires Android 5 or later. So this means that it would be compatible with any new version of Android. So because JetpackCompose is just a library that you define in Gradle, just like app compats or any Android support library. And so it's not tied to an Android version at all. So it's going to be backward compatible with all the old devices that you have. You don't need to update to a new version. And SwiftUI in this respect is quite different because it is tied to the iOS framework. So there's no backward compatibility. You always need to target the latest iOS framework if you want to use the latest SwiftUI version. And in terms of web, Kotlin actually provides very interesting wrappers to work with React. That, I would say, is probably, for sure at the moment, is the most famous and relevant declarative UI for the web. So in Kotlin, you are able to create a React app without even using JavaScript, just using Kotlin, which is quite an interesting, especially for people who are already into React and already have components that they want to reuse. But the most interesting perspective is to have Compose for web. That is, we are going to have, hopefully not very, quite soon. Experiments already started late last year by JetBrains. And we expect the API is going to be very similar to Android, to JetpackCompose. So in this way, you would be able. So if we say that the business logic is shared 85% and the UI toolkit layer is 15%, so if you want to use Compose for web, it's probably not even gonna be 15%. It's gonna be even less than 15% because you're gonna reuse most of the Android JetpackCompose. And in the future, we expect, it's pretty sure actually, that Compose for web is gonna be based on WebAssembly and not on JavaScript at all. So in the future, we can expect to have two families of declarative UIs. One is Compose by Google and JetBrains, and one is SwiftUI by Apple. So with Compose already, we can we're able to develop Android apps and also a desktop app. There are already previews, and you can already build desktop apps with Compose for all operating system, macOS, Windows, and Linux. And the web, hopefully, we don't know when, but probably 2020, next year, 1 year time, I think we're going to have a good already, version that we can work with. And then, we can expect Wear OS and Google TV as well. And in SwiftUI, you already now are able to use seamlessly the same SwiftUI components in all Apple devices and frameworks, the operating system, which is iOS, macOS, watchOS, and tvOS. Okay, so now we're gonna see one of these videos I was mentioning about yesterday's event by Google. And this is Dave Burke, the Vice President of Android Engineering by Google, which is gonna tell us a little bit more about the future of Compose. So now I have a little bit of problem because I need to have technical, let's see if I'm able. Sharing a video. Hopefully I'm able to do that.
Sets us up for the next 10 years. And more than that, I think it's a flexible toolkit. And so it's not just for phones, but I think it's going to be for lots of form factors like watches, wearables, TV,
you can just mute yourself while the video plays.
Well.
I have problems. I don't know. I mixed it up.
So you are still on mute right now.
Okay. Can you hear me? Can you hear me?
Yes.
Okay. So I'll try to play the slides. Hopefully people are able to hear.
JetpackCompose, sets us up for the next 10 years. And more than that, I think it's a flexible toolkit, and so it's not just for phones, but I think it's going to be for lots of form factors like watches, and wearables, TV, auto, tablets, laptops, and so I think it's going to serve us well.
Yeah, did you hear? Were you able to hear, more or less?
Yeah, it was good.
Okay, good. Yeah, so as you can hear from the words of Dave Burke, so this is really a very important statement. I had never heard someone from Google saying so explicitly that JetpackCompose is going to be not just for the phone. So it's not surprising. We would expect that, but a statement like that, we can really start using already safely Compose and knowing for sure it's going to be the future for all Google platforms and not only Google platform.
JetpackCompose,
okay, sorry. Now, okay, so let's have a look how JetpackCompose and SwiftUI, very briefly, the code looks like. So as I was telling you earlier, components don't have IDs. So here you have a row in JetpackCompose, which is equivalent to a horizontal linear layout. And in SwiftUI, you have HStack, which is exactly the same thing. And this structure have 3 elements inside. And you see we have these row objects with these fields. So in this, so we are basically presenting 3 text objects with some data. As you can see here, we don't have any IDs, so we just directly apply the data. And this is, if you are very familiar with the XML layout, it doesn't work like that at all. And you can see the structure of both the JetpackCompose and SwiftUI is really similar. It's just the same text with changes. To JetpackCompose is actually Kotlin, written in Kotlin, and SwiftUI in Swift, but it's really much the same. So switching from one to the other one, or converting, it's really very simple. So let's talk now about the second pillar, which is Kotlin MultiPlatform. And let's give some timeline as well. So Kotlin MultiPlatform was presented as experimental for the first time in November 2017 with Kotlin 1.2, and at that time there were only the JavaScript version. Then there was introduced the iOS version, support for iOS in February 2018, Kotlin 1.2.20. Then it reached alpha in August 2020 with Kotlin 1.4. And then we can expect, so now Kotlin is going to have decided recently that they're going to have like a 6-monthly release. So we're going to have a new release of Kotlin. Kotlin 1.5 is going to be in the second quarter of this year, and the Kotlin 1.6 is going to be in the fourth quarter. So, okay, we don't know if beta is going to be 1.5 but it's gonna come. So hopefully it's going to be beta in 1.5, maybe in 1.6. But what's important to say is that it's already mature enough as a technology, even if it was still alpha. It's already mature to develop and to start developing any kind of app. So it's not, what they call it. So the improvement they're going to happen is, so one of the main issues at the moment with Kotlin MultiPlatform is the memory management in iOS, which is, it's working, but it has some issues. And in fact, actually, Kotlin, they're working on a new version of the management of the memory management in iOS. But this is definitely not a blocker if you want to do, because you just need to follow some kind of pattern to make it work. But it's not really kind of, I'm not going to go here in the detail, but this is definitely not a blocker that would stop you. And then we know for sure that in 1.5, even possibly, we're going to have a new memory management model for iOS. So, and then timeline for JetpackCompose, we saw yesterday there was the beta, as we said, and then we're gonna be stable by the end of the year. And the SwiftUI, we are gonna have the 3rd version by June in the WWDC for sure. Every year there's gonna be a new version. So Kotlin, when we say Kotlin MultiPlatform, is like not a real way to put it, because Kotlin is a multi-platform language. So Kotlin started as a JVM language, mainly for Android, and I mean also for the backend, but it became popular thanks to Android when Google elected it in 2017 like an official language on Android, and then in 2019 they elected the primary language for Android. But since then, Kotlin has evolved incredibly, and now it's not a JVM language anymore because it's growing as a multi-platform language. So any new feature that they're adding in Kotlin, they're adding that is compiling properly for JVM, native, and JS. So these are the three targets for Kotlin. And then we are going to have a fourth target soon, which is going to be the WebAssembly. Hopefully next year, we expect we're going to be. Okay, so when we create a library, a business model, a shared business model with Kotlin MultiPlatform, we actually create a library that we are sharing in our Android or iOS or web app. So in Android, it takes the form of a jar file, a jar library. In iOS, it takes the form of an Objective-C framework, and in web, it takes the form of a JS library. So it's something which is really not extraneous. So they're really native. So a jar library is perfectly native for Android, as much as an Objective-C framework is perfectly native for iOS and a JS library. So there's nothing foreign when you are applying a Kotlin multi-platform business logic. And if we compare our architecture Dkmp with Declarative Uis to Flutter and React Native, okay, so as we mentioned, in Dkmp, we use JetpackCompose and SwiftUI for the user interface. In Flutter and in React Native, they have their own widgets to develop the UI layout. And for the business logic, we use Kotlin in Dkmp, we use Dart in Flutter, and JavaScript for React Native. But it's interesting to see how they run. So as we mentioned, in KMP, all this business logic is running very natively. You know, it's really like writing an app, you know, that is not cross-platform, is really native to the platform, which is not the same in Flutter, because in Flutter, first of all, we don't have a native UI toolkit. So in Flutter, they use this Kia graphic engine, which is a C graphic library, and there is no nativeness in the interface. So the UI actually looks the same in Android and iOS. And in terms of you know, the structure of the app, for Android it would be an NDK app, and for iOS it would be an NLVM app. And in React Native, yeah, it's true that we have native UI, and actually this was one of the main selling points, at least at the beginning, for React Native, to be able to have a look and feel which is different from on each platform. And but in terms of the code that is actually running, it's actually JavaScript, which is, as you can imagine, not very efficient on neither on Android or iOS. And your JavaScript code would be able to connect to the framework through a C++, CC++ bridge. And if you compare all these three frameworks, you can see that in terms of nativeness, in terms of bundle side, there is no comparison of what is better. In terms of utility as well, you know, if you use Flutter and React Native, you are stuck forever. So if there is like as we were mentioning earlier, if there is a new a new UI kit, or a new operating system, you are really stuck on Dart and JavaScript, and unless Flutter and React Native decide to support that, you cannot. While with the Dkmp approach, well, you have 85% of business logic you can share. You are not locked into the UI, so you are able to adapt that business logic to any framework, to any operating system. Yeah. Okay, so let's now talk about the acronyms, which sometimes make people confused, because there are a few acronyms that all mean Kotlin multi-platform. So this, in terms of mobile, recently in August, JetBrains came with a new acronym, which is KMM, which basically is Kotlin multi-platform for mobile. And when they defined and they announced this KMM Kotlin MultiPlatform model, which is really just an acronym, it's still Kotlin MultiPlatform, they also came out with a so-called Kmm Plugin, which actually it's really powerful because it allows to run iOS apps inside Android Studio. And so it means that we are able to develop Kotlin MultiPlatform apps on Android and iOS just using Android Studio. And actually, you would still need Xcode installed, but you know, if you want to run the iOS app, the simulator, it would still go through, but it's gonna be, you know, in the background is gonna recall the Xcode, but all the operation you're able to make directly on Android Studio. So it's really powerful, and it really makes multi-platform development very easy. And then you have KMP or MPP, which is like the general acronym for Kotlin MultiPlatform, which includes also desktop and web. So in terms of Kotlin JavaScript, there's going to be a very important addition by the end of this year, which is going to be the new IR backend. And this is going to really improve a lot Kotlin.js for web projects. It's going to be a big milestone for KMP on the web. And it's going to decrease especially the bundle size. Yeah, it's very, very good. So the question, so is the technology ready? Okay, I would say for Android and iOS, definitely you can start developing, no problem, really. And for the time for shipping in production, I think you don't even need to wait for JetpackCompose 1.0, I would say, because you know, beta has already been defined API stable, the beta version. So it means that everything, or maybe most of the thing, at least 95% of the APIs will not change. So you can, what is going to be changing is under the hood, maybe things like performance. I know that Android team is really keen on making really fast and really performing. So most of the work during the beta is going to be for that. So, but in terms of API, it's going to be stable. So you can really start using it without any problem. In the web, which is, by the way, it's just a matter of adding a 15% more. It would make sense to wait for the new Kotlin.js IR backend and Kotlin Compose for web. I think it does make sense to wait for Compose for web. And this is not going to be available until next year. But you know, you can already start developing your business logic, 85%, their UI, Android, iOS, and then what you just need to add for web is going to be an extra 15%. So it's not a blocker either. So you can definitely start with mobile, and then hopefully next year we can also apply to web. Okay, let's talk about the third pillar, which is the MVI pattern. So the MVI pattern is usually seen as an evolution of the MVVM pattern, which is the pattern which is currently the most used, most famous in tradition in the current Android development. So MVI is based on the unidirectional data flow, and so everything in the app follows all the flow within the app follow the same direction, and the app is based is based on a state, so which is owned by the model, and the view is not able to change the state directly unless it goes through an intent. So following the unidirectional data flow. And we're going to talk more in detail about MVI in the next slides. But before that, I think we have a new video. Oh, no, we have it later, I think. So, talking more about the MVI. So it's based on a single source of truth for the UI layer, which is the app state. You can see also from the diagram here, which is owned by the model, by the view model. And it's the state reducers that is going to make modification to the app state, and then it's going to be applied, reflected on the UI layer. So the app state consists on immutable data and can only be modified by the view model. In particular, this is the Dkmp architecture, the state reducers, as we said. And then it's based on unidirectional data flow. So what would happen is that a user would trigger an event from the UI layer. Then the model changes the app state, so takes the event, and through the event, we're gonna see more in detail, but very simply saying, it's changing the app state, and then the view applies the new state. Okay, I think now we have a video. Yes, we do. Okay, so this was still from yesterday event, which is really a milestone in this decade, so maybe, okay, at least for the year, okay. Maybe the milestone for the decade is gonna be the version 1.0, which is gonna happen at the end of this year. But this was really a very important event for Android, for app development. And there was a Q&A, which was quite interesting. And yeah, I was listening yesterday to this and really captured my attention, because Leland Richardson, which is part of the JetpackCompose team in Google, was actually expressively saying how MVI works really well with Compose. And so now we're gonna listen to him.
The state management is one of the most important things for an application. And we felt from the beginning that it was important for Compose to work well with a variety of state management solutions. And so Compose doesn't, in particular, kind of make anything too difficult for existing solutions. The Android ecosystem has really been moving recently towards the destruction of MVI. And the MVI pattern works really well with Compose.
Okay. Yeah, so
the state management is
okay. So let's go on. Yeah, so our MVI in our architecture is based on StateFlow. So StateFlow, it's a component part of the Kotlin language, of the Kotlin coroutine, which was released in May 2020, and it's part of coroutine library 1.3.6. So StateFlow enables an MVI pattern which is multi-platform, and yeah, not using RxJava. As you might expect, RxJava is just platform specific, and with the StateFlow, we are able to apply very easily this MVI pattern on everywhere Kotlin works, on any platform where that Kotlin can target, which is at the moment, which is basically everyone, every target. I mean, honestly, Kotlin at the moment is able to target for, I don't know, for everyone. Think about a language you want a library in, and you're able to do it in Kotlin. So yeah, StateFlow enables a multi-platform MVI. This is really interesting. And in our Dkmp architecture, StateFlow, as you also can see from the diagram here, StateFlow, it's what propagates the app state from the view model to the UI layer. So talking about the app state, so typically an app would be made of several screens. So it makes sense to organize the app state in substates, one for each screen. So this is just a simple example. So if you have home screen, the home screen would have its own home state with all its own properties. And so this gives us a very good structure to the app and to the app state, and very easy to work with and to pass the different objects to the different components. So about the view model. So actually the view model is a Kotlin class, as simple as that. It's a Kotlin class which has a StateFlow, as you might expect and imagine. It's a StateFlow which has the app state that we saw earlier as the type. And as you can see here, the StateFlow is a computed property. It's a computed property only with the getter and not a setter. This is because, by definition, MVI needs to deal only with immutable data. So, but of course, we should be able to make modification to the StateFlow. And we do by introducing a different elements, which state manager. And in the state manager, we define the mutable version of StateFlow. which is mutable state flow, which also has exactly the same type, which is the up state. So in fact, as you see, the getter of the state flow is actually the state manager mutable flow. And this one we can modify. And in the next slide, we can see how we can do that. Then these two things that you see inside the view model, which are events, which are the one directly called by the UI. And then the state reducers, which are the elements which make modification to the up state. So the events are defined as this class KMP view model extension functions. And state reducer are defined as this other class, state manager extension function. And you might ask, why extension function and not just simply methods, right? And the reason is that because this really gives a very good structure to our app, because methods has to be in the same file, you know? So methods of a class cannot be across different files, while extension functions in Kotlin, they can be in different files. And the possibility to be able to have this functioning in different files really gives us the chance to organize our code much better. So it makes sense. This is what the Dkmp architecture proposes, is to use this events folder and state reducers folder. And inside of each of them, there are going to be files just specific to a screen. So you would have screen file relative to screen with all these events, which are split in a very neat way. So now let's talk about the state reducer in Dkmp. So the state reducer is a function which, as we mentioned earlier, is able to create a new state. So is what manages the state. And this taking three different inputs. One is the inputs from the event, user, we're going to explain the next slide even more, so you don't understand exactly, but don't worry, it's very simple, it's not difficult. And then one other of the inputs is the repository data, and then another input is the current state. So through the state reducer, we are able to take the old state as a reference, apply some modification to create a new state. So this can be explained much better with an example. So think about an app, even if it doesn't look like an app, but think about this is an app with a list and different items. And these are cities, right? So this could be an app that is on Android or iOS, web, doesn't really make any difference. And let's say a user clicks on this list on one of these items. And what happens in our app is that we are calling an event, which is what, as we explained, is what the UI layer is capable of calling directly, which is a view model event. So, and we explained that the events are the view model extension function. So in this case, we are calling select city, which is an extension function of the KMP of the view model, basically. And we are passing a parameter, which is the ID of this item in the list. So in this case, is Berlin. And then let's see how this function is made of. So in this function, you can see set loading and set details data, which actually they are state reducers. So state reducer, what they are functions which are able to create state modification. And in a reactive app, in a reactive architecture like Dkmp and declarative Uis in general, any change to the state trigger an update of the components, right? So we have a list. So typically, let's say we want to load some data. So when you want to load the data, typically you would show a loading screen, and then you're gonna fetch the data, and then you're gonna show the other data. So in this, typically there are like two steps, two UI updates. One showing the loading screen and one showing the actual data. And this is actually performed exactly by two state reducers. So one is set loading, which is what it's doing is just changing a flag is loading from false to true. And the other state reducer, what it's doing is actually getting the data and then applying it, and also reverting the isLoading flag back to false. So seeing more in details the state reducer we just mentioned. So the set loading, what is actually doing using the Kotlin copy function, it's simply triggering this modification, is loading, and without any access to the data repository. It's just a matter of flagging one of this variable, no other. So this is no other input needed in here. And in this set details data state reducer, we actually also require to fetch data from the data repository, and then we are updating the state with the detail, as we said earlier. So recap. So a state reducer is a state manager extension function, which is taking 3 different inputs. One is the user event parameter, which in our case, was the Berlin string, which was a trigger provided by the UI layer. Then you have the data repository, which we mentioned, we saw earlier. Actually, the repository is one of the property of the state manager. So we are able to access, being an extension function, we are able to have a direct access to this object, to the repository object from the state reducers. And the other inputs is the current state. So here you see a computed property, which is state, which actually, so the state is the value of the mutable state flow. So our compute property is just for convenience, because these help us to write much better code, much cleaner code. So we are able to update the state just by saying state equal to state copy, and otherwise we would have had to write mutable state float.value equal to mutable state float.value.copy. Yeah, so much better to use this, very convenient computed property. And then let's talk about the data layer. So the data layer consists on a repository, and it collects data from multiple sources, which could be anything like web services, GraphQL, runtime objects, anything that you think about. And there is lots of intelligence in the data layer, because think about, as we mentioned earlier, so we are writing this business logic just once, so we don't have to replicate. So this is like a multi-platform business logic. We just write once, we can apply to all the platforms. So this means that we can also think about really sophisticated and smart caching mechanisms. And the repository is like a big place with lots of buttons, and can be arranged in the most convenient way. Try using any data source or any storage to do anything you want. And this allows a great flexibility. And, in terms of user experience, you can really use it to make it really great, you can think about it. That is infinite application, to that, ways to apply this. Then I want to mention about GraphQL, which in my opinion makes a lot of sense for KMP. So GraphQL, I guess many of you are familiar. So it's a way to access server data. Typically use it to fetch server-side database data. And instead of having web services, which are defined with the exact data that needs to be retrieved and provided to the client, it's actually the client which is deciding which is the data that wants. So the web services decides nothing, basically. So it's the client that decides which data they want. So it makes it very flexible, and also releases a lot of development from the server side, And this goes very much into the direction of rich client that we mentioned at the beginning. So an architecture where clients really make decision and can be so sophisticated and removes. So the point here is that we can start to have more logic in the client and less in the server, and this is very interesting. So servers, they can just focus on data provision and data availability. And actually for Kotlin MultiPlatform, there is already a GraphQL Apollo client, which is actually the most famous client for GraphQL, which is now available, even though it's experimental. is already available for Kotlin MultiPlatform, which very interesting to use. This is the last slide finally. So I think it was like more than 45 minutes. So we are probably even almost an hour. But hopefully, I think you are still following and you find it interesting. Okay, so this is the last slide, as I was saying, and this is like a summary of the libraries that we would use with Kotlin MultiPlatform, because clearly we cannot use platform-specific libraries anymore. But this is not to worry, because actually the Kotlin MultiPlatform libraries, they're even better than the other one, the platform-specific. And in many cases, actually, they wrap internally the existing platform. So this is the case, for example, of Ktor client. So Ktor client is the HTTP client, like the official, let's say, HTTP client of Kotlin MultiPlatform, which is released directly by JetBrains. And what it's doing is actually wrapping on the Android is using the native HTTP URL connection, so the HTTP client, and on iOS is using an NS URL session. So it's nothing different than, definitely nothing worse than native. It's very smart, Kotlin MultiPlatform. It's really trying to reuse as much as possible from the platform. So yeah, for serialization, we would use Kotlin Serialization, which is also a library by JetBrains, sorry. For structured data, we wouldn't use Room or Core Data. We would use SqlDelight, which is a library which has been developed by Square. And then for local settings, we would use this library, multi-platform settings, which is also actually wrapping the shared preferences in Android and as user defaults in iOS. And then for concurrency, we would use Coroutines, which is actually what Android development should use anyway. And so this is the last slide. And actually, I wrote an article on Medium where, if you're interested, you can go more in detail, learning about this architecture. And if you have any question, feel free to contact me in Twitter. This is my handle. And if you want to look for the article, you can just Google the future of apps, or just type my name, Daniele Baroncelli, and Dkmp. Yeah, if you type Dkmp and my name, you easily find it. Or if you, something like this.